in now. Can you hear me?
Yeah, I hear you.
You hear me? Okay, I think I can hear me.
You hear me?
Can you hear us? All right. Welcome to Mod City episode number 3. Mod City Live, Voltage Control Lab. I'm Joe.
I'm Victor.
And we're going to talk about LFOs today. Hey, Wambra. I hope I'm saying that right. That's some great emoji work right there. All right. So, what's happening this week? I hope you guys got a chance to check out our interview with Encanti on Monday. If you didn't, please check it out. It was an enlightening conversation. He's just an incredibly bright individual. I think a leader in the sound design community. Maybe one of the most creative people that I've known in years, and just exciting to hear his perspective on things. So I hope you guys get to check that out.
Very good spirited.
So yeah, he's just a very exciting person to be around, and to hear his music, I think really it breathes that same kind of life that he has. So I hope you guys get to check that out. Really exciting to hear his stuff, and to have him in LA for the first time in years, and him and Zebler, who's another just incredibly inspirational person and an artist. So yeah, hope you guys get to check that out. Glad that we've got a couple of people here who have seen that. Thanks for checking it out, Wambra. All right. So a couple of things to mention, I guess, since we like to start out with, things of note in the industry, things that might be useful to know, information that might be valuable to you, and it's the holiday season. I'm gonna bring this down a little bit. Lots of free plugins, especially. I think we'd be hard pressed to find a lot of free modules if you guys are looking for that. But if we hear about it, we'll let you know. Contests, things of that nature. But lots of free plugins right now. A couple of great reverbs. Native Instruments released their new reverb. Realm. Let's see if we can bring that up here. This is it. If you Google Realm, R-A-U-M, and Native Instruments, we'll put the link in the description later. Realm is really interesting plugin. I've already made a track with it. I opened it up to try it out, and I put it on a kick drum, and kind of instantly gave me this vibe, and so made something out of it right away. I think it's got 3 different modes, each of them kind of their own characteristic flavor. Freeze mode, it's got all of the characteristic stuff you expect to see on a reverb, but it's got a little bit of character and flavor to it. So I would highly recommend checking it out. It is free as well, and this one's maybe a little bit more current, futuristic in its mentality, I suppose, compared to another free plugin right now from Arturia. This is based on the first plate reverb. This is the Reverb 140, plate 140, something like that is what they call it. Arturia.com/reverb-gift. Could use, just made it one of those, I suppose. But really great reverb. Tried this one out as well. This one's a little bit more maybe classic sounding, but really it's got an internal drive circuit, some filtering of the input signal passing through the reverb. Really nice and interesting plugin. Now, one thing to mention here maybe is that there is blow that up a little bit there. For both of these plugins, you have to have the appropriate company's registration software installed, which
Basically, it's a cloud manager. That's what these companies,
sort of, yeah. I think it's that this is how it's online registration. This is how companies have done this for years, and certainly they want to capture your information so that they can advertise to you. But such is the case when we get stuff for free these days, it seems. But I mean,
that's
in
an
my
awesome reverb.
in my opinion, these are both no brainers. They're extremely good, and these companies tend to give stuff away every once in a while. There's also a free limiter available. Peter Kern posted about it this morning, I believe, on Create Digital Music, cdm.link. If you go to their website, you'll see this as one of the top options. I don't want to pass along a link that will bypass their whatever link they have set up here. This is a deal with audio. I don't know if this is a deal through CDM or whatever, but it's a deal via audio plugin deals. And if you click on this link, you can get the IK Multimedia 1176 compressor limiter emulator, which is it's a classic emulator, a classic limiter. One of the more commonly sought after vintage limiters. So that might be of interest to you.
Be good on vocals or drums.
Yeah. Yeah. Of course, worth mentioning now that you mention it here in the comments, Wambra, that Arturia does have some incredible other instruments and plugins, as does Native Instruments. But Arturia does have a lot of, especially modular-friendly, synth maniac triggering plugins, right? Like the Buchla Easel and Prophet, and a lot of classic instruments that make synth nerds shiver with excitement. So, something to take a look at as well, I suppose, if you're into that stuff. And but hey, I just like the free plugins. I just want that free reverb. Give me more. I have to say though, I'm actually very picky about my plugins, as Victor knows. I don't like to load up my computer with random plugins. I like to keep it pretty lean, but stuff like this is hard to pass up. So
yeah, pick them wisely, right?
Yeah, and if you're starting in modular, let's say, or you have a synthesizer, you're building some sort of synthesizer, maybe. Having color to the sound is maybe an important element, right? Giving a little bit of character to the sound beyond the otherwise dry and drab signals coming straight from the oscillator. A little bit of reverb might be a nice touch. And that's something that we can maybe take out of the modular synth. Maybe we'll look at ways that we can make all of these things come together in the near future, using CV tools of some nature or another. But at the end of the day, I think free stuff is always nice. Also worth mentioning, this week, our colleague Drumcell announced the upcoming Black Noise Party, which usually, for 10 years now, has accompanied NAMM. NAMM is coming up in under a month now. Under a month now. And NAMM is sort of it stands for the National Association of Music Manufacturers. I think so. I think that's right. Correct me if I'm wrong, chat room. But NAMM is effectively a meeting ground for all the people in the music industry every year to come together, to hawk goods, to get pitched on, business proposals. It's really a place for dealers, music retailers, to come and learn about new products and, and buy those things in bulk, ideally in the eyes of the companies that are showcasing their stuff, right? They want to sell a lot of gear. So, but they don't sell stuff on the floor. It's more of a, dealer to manufacturer mindset. That's originally the idea anyway. It's become more of a gear fetishization uh, opportunity for some people. A lot of people clamor to get to NAMM so they can see what's new, what's coming out, what's the newest, hippest stuff. And hey, Kale, I hope I'm pronouncing your name right. Hey, Jolie, I see you up there. But NAMM is also an opportunity for everyone to kind of get together in one place every year and see each other. And so, National Association of Music Merchants. Thank you. That's much better. Maybe encompasses more than just manufacturing, like I was mistaking, right? But the NAMM show is also surrounded by other events, right? Everyone comes to the LA, Orange County area, and then people after NAMM, after working at NAMM, some people anyway, like to then go and hang out and see people in a more social setting, to actually listen to some music, because NAMM also brings to LA all of the big musicians from around the world. Every company wants their appropriate artists of their scene to come in and hawk their goods, to do I'm maybe minimizing this unfairly. They want people to come in and help to validate the quality of their products, right? They want artists to come and show off how cool their stuff is so that people will want to buy it. And so those artists are in town, and that's an opportunity. So Drum Cell for years has been bringing, and his crew of other artists in Black Noise, who include Surachai, Richard Devine. I'm probably leaving some Polyfuse, I think, right?
Yeah.
I think it's those guys. It's the kind of the trash audio guys. And so he's been doing these events around NAMM for years, and they're some of the most forward-thinking events in LA, aside from just around NAMM. So this event was announced this week. You can go buy tickets if you're going to be in Los Angeles, if you're going to be around Los Angeles. You can go on Resident Advisor. You have to search BL__K. That's the Black Noise. If you just look up Black Noise, you might find something else. Dirty Epic. So this is, again, we'll put a link in the description after this, but you can get on the kind of I guess early bird is sold out, but first release ticketing. The lineup has not been announced yet. The lineups in the past years have been
ridiculous.
Richard Devine, Surachai, pretty sure Anthony Baldino played last year.
Some of these names, oh man.
Who else? Alessandro Cortini, Belief Defect, Drum Cell, of course. Truncate, I'm sure, has played in the past. It's always a next level lineup, and I would just recommend you get on it early if you're going to be coming to LA for NAMM.
I'm trying to think of the guy that played the break set. That was outrageous.
Yeah, last year was a Raster label showcase, and that was really incredible. Very heavy, hard-hitting stuff. But
Greg does the visuals, and I think that's a big part of it.
Octaform, right? Yeah, absolutely. I mean, the visual aesthetic is, I think, a big part of Black Noise as well. So, really, next level business. And then maybe the last piece of worthwhile news here, at least it's come across my purview this week, that maybe will lead us into our discussion for the day is DivKid released another module, the Oct. I think I'm pronouncing that right. Um, Really interesting module. Um, uh, in modular there are kind of fundamental devices, things that we aim to use to have probably in most systems, so that we can create common uh, uh, common musical forms, common signal flow uh, 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 techniques, let's say, routings. Right? We often have oscillators. We often have envelopes and VCAs and filters, maybe, or distortion tools. We might have audio effects. We might have LFOs, which we're going to talk about. And often we'll have kind of certain expectations of these devices. And we're going to talk today about some of those expectations with regard to LFOs. But sometimes you get other types of modules that are a little bit different than those fundamental devices, that give you a little bit of character where the fundamentals might be a little bit uh, flat, predictable. It's the predictability that makes them useful in a fundamental nature, but it's the unpredictability of some other devices, the character, the flavor of some of these individual devices that make them exciting and make them feel different and special, and they give results that are atypical of those fundamental devices. Sometimes the two may meet, and I think this is a device where those things sort of come together. This is an 8 LFO module. Let's turn down the volume here. Hopefully, this isn't blowing you guys out right now. But we have 8 LFOs. What do those LFOs look like? What are their relatable tempi, rates? Well, each one is different. Each one is sort of a fluctuating LFO shape, less of a common LFO shape like our sine waves, sawtooth waves, square waves, triangle waves, things like that. There might be some of those things in there, but the device is really built on the idea of having 8 strange LFOs, less typical LFO shapes, each one independent from the others. Their general rate and speed controlled by that rate knob. But you see here, each independent core is free running with rates configured from fastest to slowest from top to bottom. So we have faster modulation happening at the bottom compared to, or at the top, I'm sorry, compared to going down to the bottom where we're going to have slower modulation, which might be, I wouldn't, probably are not just basically clock divided or subdivided in tempo, but it says free running, right? Each frequency range was tuned by ear during development to give the optimum speed of control frequencies running in parallel. So the idea is to have some sort of relationship there, but it was done by ear, not by math, and it was done by obviously then a human. So there's some relatability in terms of these shapes, but uh, there's a human element here. It's not just based on pure divisions of time, pure systems of relatability from one LFO output to the next. Each one is a different shape. That shape is uncontrollable, it seems, other than that rate control. 100% analog, the LFOs will phase organically with the ability to ebb and flow together with the global frequency control. So we can kind of get them, into a range where they work together, but they seem to run frequently or freely, and to have a independent phase relationship. So modulation breathes life into otherwise static patches, as it says here. I think that's an incredibly important point, right? Modulation change is one of the most important things in synthesis programming and sound design shaping. If there's no motion, if there's no change, if there's no feeling of development in that sound, it's going to sound dull and flat. So this is a device that will give us some unique results. I would highly recommend you guys go check out DivKid's video on this. It gets into some detail about how each of these different shapes relate to each other, and yeah, very interesting thing. I believe it sold out pretty quickly, so they're probably trying to make them uh, right now. This is also in partnership with Instruo, who we've worked with before. We used one of their Scion modules, right? That was the plant module, a module that uses a plant biofeedback, or really just a biofeedback controller connected to a plant or a human or whatever you want to connect it to, and generates other CV signals based on the biofeedback signals coming through this sensor. And they have some other incredible modules they've been putting out. Really
They look good.
works of art. Yeah, they're not just beautiful and interesting sounding, but they're also just
Crafted nice.
yeah, amazing pieces of art themselves. All right. So, all right, we got a couple people in here. Does DivKid design his modules? I'm sure he had some hand in it. This maybe goes back to our discussion last week. Was it last week? Yeah, about Tom Whitwell's Music Thing modular notebook, the modular design notebook. I would highly recommend you guys check that out. I think it's being sold through Thonk, and in it, it's got panel layouts that you can design on. Something that Tom Whitwell has kind of demonstrated in some of his posts recently. This is the Oct is a 4 HP module, so that's fitting a lot of stuff into a very small form factor, and keeping it interesting, keeping it different. So I'm sure that he did have a lot to do, if not everything to do with the design of that module. But it seems, it looks like it's a combination, a collaboration with Jason at Instruo. So hard to say. I think he has another module, the mutes. I think it's called the mutes module. It's 4 channels of mute switches. Very cool module as well. So yeah, looking forward to more of that DivKid style in terms of these module designs. He's got a different eye for that stuff. So okay, well, speaking of LFOs, we're going to talk on the more fundamental side today. We'll talk maybe about some of uses of these things, and these LFOs that we're going to get into right now. Let's come over to, whoops, that's the zoomed in version. Let's come over to the modular side over here, and we're going to turn off this music. Rather, we're just going to reconfigure this patch slightly. Excuse the thumping around getting my mic settled here. Okay. Much better. Let's turn this off for a second. All right. So today we're talking about LFOs. We're going to talk about, we're going to use for as our example LFO device today, the quad LFO from Maleko, simply because it's got some of these really expected, desired controls that are, really fundamental to LFOs. So we're just going to turn down a couple of things here. I'm going to try to tighten this up. There we go. All right. Let's see if we can get this thing to do what I want. All right. Do this. All right. So let's see what we got. Okay, so uh, LFOs come in many forms. We had a um, poll this week on the YouTube channel to see what people's favorite LFOs were. Um, the Shock XAOC modular, I can't pronounce that name. Uh, Batumi, that's the module. That was the winner. Batumi is a 4 LFO module that does quadrature LFOs. It does, which is a phase relationship from LFO to LFO. We'll talk a bit about that. But a device that has quite a bit of modulation built into it, where we can modulate frequency, things like this, all the functions that we might want to change inside of an LFO via, or most of them anyway, via CV. Uh, we also had maths up there. Maths is, of course, a common favorite for LFO purposes, envelope purposes, doing voltage math. We're going to make use of maths today, even whether we turn it into an LFO or not, because it's a useful thing for manipulating almost all CV. Couple of other popular ones on there. Check out our YouTube channel for some other options there. One of them was the quad LFO from Maleko. And this device maybe connects some dots between how we maybe have experienced LFOs in the past. That could be through software. That could be through LFOs that are connected to hardware synthesizers or other modular LFOs. But it's got a lot of the functions that we expect from an LFO, whether we've encountered one from Serum or from maths or from using any other oscillator, maybe. Okay, so a couple of these functions might be rate. Okay, I've got the image might look a little bit blown out, so that this will be a little bit more visible. It's kind of hard to get the right kind of combination of light here going here to get the screen on this to light up bright enough, but maybe it'll work. So we've got a few things. I've got one LFO currently selected on the quad LFO, and this currently selected LFO, LFO1 here, is routed so that we can visualize it on our screen. It's also routed out so that I can patch it somewhere inside of my system, inside of a very basic single oscillator voice with a filter attached to it. No volume control right now, really, but we're going to hear that single voice, and we're going to patch the LFO around in a moment to see how it will affect the system in different ways. But maybe paramount to this process is to hear what exactly is happening thanks to this LFO, how this thing is going to affect other things in the system. Maybe the easiest way to track that is with pitch. So we're going to, in a moment, turn up one of our oscillators. Okay, let me turn it up a little more. That's a little bit better, maybe. Okay, so it's tracing this thing kind of slowly. You can see where it's resetting, right? It's scanning across. Okay, and now we're hearing a wave from braids coming in, and we might have to turn that up and down occasionally to see what we're doing. So maybe the most obvious thing that we can attach an LFO to hear and track its motion is going to be the pitch of an oscillator. And there might be, functional reasons to do that, like to get common modulation effects. For instance, vibrato. That's one of our maybe most common uses of basic uses of an LFO, and in a simple basic patch. And so we might patch this thing to the pitch to hear its effect, and we're going to very clearly trace that as opposed to maybe other parameters in a patch. So we can turn this up. And I need to patch that in. Okay. So we're just going to patch it right into the 1 volt per octave input, which might seem insane, but because generally we might not want to do that, But, okay, now, as we dial up the, notice that right now there's no signal, there's no alternating current on our screen, okay? The level, the amplitude of our LFO can be controlled in this particular LFO. Not every LFO is going to have that function. And as we increase the amplitude, the level, we increase the range of pitch change, right? So as we reach that full level, we start to see the full range of the peak-to-peak modulation of this LFO. It's going, we can see each, maybe you can see on here, there's little boxes in here. This is going about 2.5 of those boxes. Each box is equal to 2 volts. So this is going from a peak-to-peak range of plus 5 volts to negative 5 volts at the bottom. Okay, so 10 volt range, oscillating around 0 volts, which if we turn the level back down to 0, we should see it basically just sitting down there. We hear no pitch modulation, and as we increase that level, that amplitude, now, many LFOs might not have a level control. Many LFOs, we might have to route through a VCA, right? This is effectively acting as a VCA with a CV offset, right? Allowing us a DC offset, allowing us to turn up and down the level of that signal passing through a VCA. This is kind of built into the background of the device. It's great if that level control is on there. Plugins, we might see that built in. The amplitude, the intensity, the depth control of an LFO, right? If we assign an LFO to some control in a synthesizer, we have to assign maybe also that intensity, that depth of modulation. Here we have that built into the module. But if we had a really basic fundamental LFO, that level knob might not be built into the process. We might have to send it through VCA and then attenuate, open and close that VCA accordingly to get control of the level. It might otherwise only be coming out at plus 5 to negative 5 volt range, or a full bipolar range of signal. Now, other controls on the panel here: frequency, or the rate that this LFO rises and falls. Excuse me. Now, excuse me. Got a horse in my throat. Frog in my throat. Horse in my throat. I don't know where that came from. Okay. So, frequency control is the rate of modulation, the rate of rising and falling signal. I don't know what happened there. I was talking too much. Now, as we raise and lower that frequency, we see this rising and falling happening faster and faster. More repetitions within the same amount of time. This particular device gives us a couple of different rate ranges. Okay, down here we have slow, fast, or tempo synced. Okay, so mod amount is a VCA on stuff. Yes, pretty much. Usually that is the case. Modulation intensity, amount, the depth. This is effectively a VCA allowing you to set a range or maybe even control that range, right? Sometimes we have both the assignment range, or we have even, in addition to that, an amplitude knob within the LFO. And that's kind of what this level knob is. We could still send it through a VCA and have other control, right? Have some modulated control of that level. That might be nice to have, but a thing to look out for. Now, okay, so amplitude is a nice thing to have control of. Rate is going to show up on any oscillator. Now, this might not be measurable on hardware controllers, right? On on plug-in synthesizers, on Serum, on Massive, on any plug-in synth, we probably will have very accurate control of frequency and rate of an LFO, right? Or of an envelope for that matter. We might have millisecond level control. It might get that granular. We might be able to set our LFO to precisely 3.22 hertz or something like that. Here we might have to measure that with an oscilloscope, which might be an inaccurate way to do this because we're basically doing it by eye. But we have to use our ear quite a bit, unless we're in tempo mode. If we switch to tempo mode, then we might be able to get a clock-based result, right? We should be able to if it's got a tempo-based control in there. And that might be a little bit closer to what we expect from our plugins, from our synths that we're more familiar with, perhaps. This will give us repetition that, or frequency controls, frequency divisions of a clock source up to the exact tempo of the clock coming in there. Half tempo, quarter tempo. So we can send in, say, a 16th note pattern or clock. I'll say we don't want to send a pattern, though that might get really interesting if we do. If we use a clock at 16th notes, we can use the frequency control in tempo mode to get some divisions, and we'll look at that in a minute. A couple of other very important controls here that we're going to see. Shape, right? We might want different shapes. Now, certain LFOs might have shape outputs where each different shape is dedicated to an output, as we might find on an oscillator, especially an analog oscillator. But as we change the shape here, we're going to see that we go through some of the basic shapes that we're expecting. Let's turn this up a little bit. And let's limit the level. Okay, so there we have like a sine wave based shape. We can switch to fast mode. That's the slowest setting in fast mode. We very quickly get into audio rate. So we could even route those out directly to a mixer and hear those waves at those rates. Basec does some great stuff with the quad LFO oscillators. Okay, so let's take this thing. Let's turn this back up a second. Let's go back to slow rate for a second. And let's take a look at the other shapes. So here we have our sine wave. As we start to move from left to right, the shape starts to morph. And we get something that looks more like a ramp wave. Go the other direction. Sorry, not the other direction. We keep sliding that slider over. This is like a wavetable, right? We're sliding over to now a triangle. Keep sliding over. We got a proper sawtooth wave. The opposite of a ramp wave, right? Oh, we gotta slow it down there. There we go. And if we keep on going, we're going to get a pulse wave. This is absolutely a digital LFO. Our analog LFOs, we're we're going to end up at a square wave here. Pulse wave, then to square wave. Yes, so absolutely. This is a great question, Wanra. This is a digital LFO. We know that because it's doing this. I mean, we might know because we look at the manual or you know, hearing this or learning from the actual manufacturer that it's digital LFO. But when we have a wave shape control like this, it's effectively using a wave table, a one side to the other side morphing list of wave shapes, right? So in an analog oscillator, each one of the wave shapes is going to be a static output, most likely, unless there's some internal mixing going on or something like that. Each one will have a static output for whatever shapes that they might be generating from that device. Each one will require a separate, of course, oscillator core, and so that means that usually we find those things separated at the outputs of the device. If we look at something like the Z3000 from Tip Top, or Maths for example. Now Maths is an analog LFO that we have control over the kind of like rising and falling shape. We can go kind of between sawtooth, ramp, and triangle waves with some variation as well. But one thing we'll also not see so often on maybe ever on an analog oscillator is a perfect sine wave, which we'll get. I don't know if it's a perfect sine wave, but it's a nice, pretty clean looking sine wave here. So the shape effectively gives us a morphing path between sine wave to a pulse width square wave, stopping at a ramp wave on the way, a triangle wave on the way, a sawtooth wave on the way, and then some interesting amalgamations of the in-betweens of those as we go, right? Like this thing is kind of like half sine wave, half weird spike, right? Like we're starting to get some strange and interesting shapes that are being generated here. Maybe if we increase the size here. Then maybe for some extra spice on top, we've also got the ability to distort these waves. So we've got some wave shaping, some distortion, and then noise, which increasingly, it's kind of divided, the slider is divided into three modes, each one increasingly, or three, areas, I'd say. We slide it over to around here, and we get this wave shaping, I believe is what it's doing. And then we get a distortion, and then, or maybe that's bit crushing, sorry. You can see it's actually turning this into steps, especially if we turn that up here. Kind of some noisy steps because we're over on the side here. There it goes. So it's downsampling. And then we get noise distortion. So we could listen to these waves, and maybe we'll do that. But the idea here is that we're getting some very complicated wave shapes. We can use the shape and the distortion functions here to get even more complicated waves. Take a sine wave and jumble it up. So, we can get some pretty interesting results. And then I wouldn't say this is, downsampling is maybe not the most stable way of creating a sequence, but it's creating something kind of interesting there. Okay, so let's turn that back down, and we'll come back to our sine wave. Let's turn this up. Okay, now the other option we have here is phase control, and phase gives us the ability to offset one output LFO from another, and this allows us to create contrasting shapes. Similarly or precisely timed LFOs that have some offset beginning and ending times. This can result in maybe interesting musical combinations, rhythmic combinations. One commonly used one, especially with 4 LFOs, is called quadrature LFO, where each LFO kind of in succession starts at a 90-degree angle later, a 90-degree delayed starting point from the previous LFO. Visualizing this might be challenging right now, but let's take one of these other LFOs and okay, this is going to be hard to see. Okay, let's try this. I'll have to just hold this back. All right, so we're going to turn on this one. Okay, so there's one LFO. We'll turn on the other LFO. Okay, and we will slow that one down. Let's set them both to fast. And then the same frequency. Okay, so now they should be running really in synchronization here. They're not starting at the same time. So we'll need to, maybe one quick way to fix this up would be to send a clock into our LFO. Again, this is something that we don't always find on LFOs. And we'll set these both to tempo. And look at that. Now they are perfectly in sync together. And let's speed up the frequency. Maybe not quite that fast. There we go. Okay, so now they're both going at the same division of the clock that's being sent in. Okay, so let's go to number 4 here. Can you guys see that blue one? Let's see if we can actually see it when we start shifting. Yeah, there it goes. We can see it there. Okay, so they're currently both in phase. They're both starting at the exact same time. They're both resetting at the exact same time relative to the clock, the incoming clock that will retrigger them. We're not technically retriggering. We have gates input to retrigger, but we're now tempo syncing our LFOs essentially. So now I just threw it out. There we go. Okay, now as we shift the phase of one of these, we're going to see that they both still stay completely in time, but one is going to be offset in time from the other. Now, we could patch the second VCO, hopefully you guys can see that, into the FM input on our oscillator. And now the rising and falling signal on the pitch input, if we turn up the FM input, we're going to have the inverse shape now, almost the exact inverse shape of that LFO, which should counteract that frequency modulation, that rising and falling pitch. Now, as we turn up our FM, now we're turning it up and down at the exact same time, almost precisely inverse with each other. The FM input doesn't seem to go all the way up to +5. course, if we put them perfectly back in phase, if we put them back in phase perfectly, we end up with those two LFOs adding together, creating double the pitch rise and fall. Right, we're going now plus 10 to negative 10 volts, and that sounds like even more pitch change. So, get interesting results out of this thing. This is not exactly a preferred use case, but I thought this might be a way to kind of see how these things can counteract each other. Maybe we'll come back to another way. I think we'll just do another day on quadrature LFO. It's a subject matter that we can make quite a bit out of. But we can offset the phases of these things, and especially in tempo mode, that might yield some interesting results. So, frequency or rate, level or amplitude, shape, certainly, phase relationship. In a digital oscillator, this is especially the phase is something that we can usually control like this, but maybe in an analog LFO, it would be a little bit more challenging. Okay, so let's see. Let's talk about some common uses of these things because, I think this is another maybe important element here. Okay, let's talk about maybe the three most common uses of an LFO. The three most boring fundamental uses of an LFO. One, of course, what we've been doing now, controlling the pitch or frequency of our oscillator. Right. Let's simplify our patch here. Okay. And okay, so now we should see, I think, a little bit clearer what we've got. All right, perfect. So we're gonna think about this in a couple of ways. One is that we don't just want to have vibrato on our pitch, right? That would be really boring, like this is. Now that's much higher amplitude than we would want for vibrato. Much slower than we might want for a vibrato. So let's go into slow mode. And let's see. Okay. There we go. So a couple of things about vibrato. A, we usually do it in combination with pitch change, right? So we want to be able to control the pitch of our oscillator via maybe a sequencer, maybe a keyboard, whatever it is that we normally will patch into the volt per octave input. So that's one bit, right? That's the 1 volt per octave is probably already taken up by our normal control mechanism, our sequencer, our keyboard, whatever that might be. And that means that the vibrato needs to be somehow added together with that signal. Now, if our oscillator has an FM input, we usually think of that being the input for another oscillator, right? But guess what? We're using another oscillator. So we might be able to use that FM input, especially if it's an exponential FM input, though I think linear will work fine too, because we're talking about very small ranges of frequency for vibrato. So we can bring in that note, whatever that note might be. And then using the FM input, we can maybe, hopefully, even further attenuate the signal coming in from the level, or from the LFO. Let's send that LFO out. And so now I can use the FM input control on the oscillator that I have plugged in, which is, in this case, braids, to further control that level. I could even set the level very low here, open it all the way up on the FM, and then dial back the FM control. This also sounds very seasick for vibrato, because vibrato is usually faster than this. Right? It's not usually like 1 cycle per second, which is about where we're at here. Let's put it on fast mode. We can dial back the FM if we want it to be subtler. And we might want to be able to control when and how that vibrato happens. So we might even send that LFO through a VCA. We might control that VCA with, let's say, a knob, or if we're using a keyboard controller, the mod wheel on that keyboard, right? If we're using a CV keyboard, then it might have a CV assignable modulation wheel control, right? That's what people often use for that. So we slide that mod wheel up. It opens up the VCA, effectively opening up the level control of the LFO, passing it into that FM input so that we can keep playing on the keyboard routed to the volts per octave input. And then we roll that mod wheel up and we get this nice allowance of the intensity of that signal passing through, and we can control that. So vibrato, one of the most common uses of an LFO in, just basic musical patches, I suppose. Now, this might have no bearing whatsoever on the music you make, but again, this is just a common application of it. And once we speed up the rate of that LFO to to those fast settings, and we increase the intensity of the LFO or the FM input, maybe. We can start getting into maybe some FM type patches. Right? FM is frequency modulation. Vibrato is slow modulation of the frequency. So they're relatable. Not the same thing exactly, maybe, but very relatable. Okay, so FM as a vibrato input. That's one way to use our LFO. Maybe another way to use our LFO would be on two of the other very basic elements that we often find in a patch, volume, or maybe filter control, right? So if we want to do volume, let's say, I can unpatch our volume control for our VCA, right? Instead of using an envelope or an offset, if we're using drone, if we're making drone music or something like that, which is what I was using a minute ago, we can patch an LFO into the CV input on our VCA. And when we do that, maybe speed up the frequency a little bit, we can get another commonly heard use of the LFO. Let's try another shape here. Tremolo. Play around with those shapes a little bit. Square wave is kind of abrasive on volume control, but go fast enough, you get something like amplitude modulation. Okay, this is controlling volume. All right, audio could be a little louder. Sorry about that. So, amplitude modulation. Might even get into some ring modulation. I think we need a little bit of a different patch here for that to work. We'd need maybe another VCA. But now we're getting into some interesting stuff. This is, again, just using an LFO. Thank you for that heads up. Hopefully that gets a little bit better. Let me know if it doesn't. The uh, the LFO to pitch, controlling very slightly the pitch, or in this case, maybe drastically the volume at slow and fast rates. Very useful, musical, potentially destructive, distorting, interesting stuff. Okay, another maybe very common use here would be instead of modulating volume, we could modulate a filter, right? Let's try sending a filter through here. This is maybe the core of, dubstep, right? Things like this. So, not that this is tied only to dubstep. This is the core of shaping, modulating the tone, right? So let's find a tone that we can use here. Whoa. Right? Something that if we open up that low pass filter, we hear the the bright tones, the overtones, the harmonics coming through the filter, right? So now we're going to take this, we're going to turn it up, we're going to route this LFO to control that frequency. Whoa. Seeing something weird there. Okay, there we go. Okay, so that's just controlling the low pass filter. Let's send in the LFO. Okay, well, I've got it going into the FM input, the frequency modulation input on the filter. So let's turn this up. Right, maybe very important to attenuate this signal, to control the amplitude of this signal. So, we could do that from here again. Open up that. Right, that's basically just a square wave. Basically a square wave going through a low pass filter, but we're modulating that low pass filter using our sine wave LFO. Now, if we turn up that frequency, the rate of modulation here, we start to get to a point where we might get filter FM, where now we're modulating the filter frequency so fast. Ooh, now we're talking. Great idea there, Wambra. Let's try that out in just a second. Right? If we turn up the resonance on this filter, all right. So, filter FM. Sometimes we see that on our plugins. right? Sometimes we see that we're using ripples right now, which is kind of, I think, not accidentally named after the sounds we're getting here because it's inviting us with an FM input to frequency modulate that filter. And especially when we turn up that resonance, we get these really wet type of sounds. These really, it sounds bubbly. It sounds like, some synthetic river or something. So, um, filter modulation, another very simple, very basic way of modulating our our patches. Um, so I think now might be an interesting time based on Wambra's patch idea there, right? Using modulating maybe lightly a hi hat pattern to give it a little bit of motion, give it a little maybe a little bit of humanization, especially if we start distorting our wave shapes. That might especially give us some interesting results. But um, the idea that comes to mind here would be let's take a hi hat like pattern. I'll just program one up right here. So this is going to be using the Basimilus iteratus from noise engineering, simple and quick hi-hat, right? Okay, and then we're going to modulate the decay time, right? The built-in envelope length, something like that, right? Which I think, and I'll turn that up in a second. Hopefully it'll be a little louder. Something that we can get a little bit of tracking here. We're going to use the same clock, and we'll tempo sync our LFO here. Okay, LFO one is now tempo synced. It's going to be going once we turn up the level at a rate tied to the tempo. And let's hear what it sounds like. Okay, and we're going to route that over to the decay input. Uh-oh, if it'll reach. Okay, let's do this. Oh, that's fun to listen to. Oh, yeah. Okay. Okay, so here we've got a hi-hat coming in, right? Yeah, absolutely, Wambra. All the things that we just looked at are generally routed, pre-routed to synths that we might see off the shelf, right? Semi-modular or hardware synthesizers, especially, um, are likely going to have vibrato built in. They might even have a hidden, an unseen LFO that you just have control over vibrato rate, and then you rock the mod wheel to turn it up. We might have a separate LFO that could be routed to these three elements: the filter, the pitch, the amplitude, to get additional controls of those devices, in addition to, say, our commonly used controls for volume, let's say our envelope, things like this. Modulating a hi-hat clock, ooh, that might be interesting. Right now we're modulating, if we listen to this, we're using a tempo synced modulation, so we should hear it every 16 steps or so. The same shape is kind of, right? 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Right? It's relative rhythm. Now it's going double time. Try different shapes. You can try distorting it. Not quite as repeatable, but I love that idea of let's modulate the clock. Maybe we modulate it. Oh, yeah. Let's simplify the shapes. There we go. Now that's some interesting business. Yeah, really great idea there. Great example. They were modulating the tempo on the clock that I'm using to trigger the hi hat, and because we have a more solid clock that's tied to both that other clock. So as it's modulating, it comes back to the tempo that we're using also to sync our LFO to. There's some musical connection there. There's some rhythmic connection since they're all based off of the same master clock, right, or lead clock. So this is again something that's a little bit extra controllable because we have a tempo-based LFO and we have really that's what's making it controllable. As long as we have that, all of these other things can sync up together with it. Now, one other maybe important thing to mention, and then we'll end it for today, is that we might use. Where did that go? Oh, there it is. Okay. We might notice that, especially if we use this routed to control pitch again. Let's bring this back over here. Open up our filter again. I'm going to. There we go. Let's simplify our shape. Okay, so now we're getting in the right direction. Now, we're going to notice very quickly, and we mentioned this earlier, glossed over it, that this is a bidirectional LFO, meaning it rises and falls above and below a 0 point. When the level is at 0, it's in the middle of the rising and falling shape, right? This gives us a, uh, uh, a rising and falling pitch around the centrally tuned pitch of the oscillator. So as we listen to this, and we increase the level, it rises and falls around the 0 point, right? It's going up and down, and at the middle is our original pitch on our oscillator. This is bidirectional motion. Okay, we go up and we come back down below our original position, our original set parameter. We might have, or we might want unipolar results where we go up from the pitch that we're starting on and then come back down to the pitch that we're beginning on. So we might need, some devices we might find have a bipolar or unipolar function, especially in the digital world. In the plug-in synth world, we might find bidirectional or unidirectional switches that allow us to flip from bidirectional modulation to unidirectional modulation, which is something we maybe often see or expect from an envelope. We start from 0, we rise to 100% full value. In the modular world, that might be 5 volts, something like that, and then we fall back down to 0 volts. But here we start at 0 volts, we rise to a positive voltage, we come back down past 0 into the negative and come back up. And we can think of that as kind of turning a knob for us effectively, right? Turning it up from its current position and then down below its current position and eventually back to that current position, or never back to that current position if it continues oscillating. But we might employ a couple of other things. Now, we've already got the modular, or I should say the attenuation. Okay, the attenuation is the level control, going from 0 to a certain range, 2 volts to negative 2 volts, increasing that range. This is attenuating the signal, controlling the range, the level, the amplitude of the signal. Okay. Now, we might also want to offset that signal. And for that, we may need another device. Unless our oscillator has that function built into it, which this one and few do. Maths happens to have an offset function in it, luckily for us. So we're going to send this LFO through maths, through channel 2 on maths, which is in and of itself an attenuator, an attenuverter, okay? And then we can use another channel on maths to add, to offset or subtract, offset into the negative range, the voltage range. Okay. Let's see, 2 identical filters in reverse to make the notch filter. That could work, sure. Variable bandpass filter, variable notch type of filter, sure, could work that way. You'd have to use you'd have to set up your filters in the right succession, and but that could be an interesting musical application of these devices. Absolutely, you'd need multiple filters also. So, but yes, I think that sounds like a usable application. So right now, let's get this thing routed the right way. Let's route this LFO up here. It's now going down. Oh, okay, that's right. We're going to use LFO2 for this. And LFO2 is going to be routed back around using this. There we go. Okay, so now we've got LFO2. Let's visualize that. That one's off. This one's on. Okay, so there's LFO2. And we need to, that would be helpful. Let's just do this. Boom. Okay. I'm breaking it. No, there we go. Okay, so we have our level control. Just reset this whole thing back to all of its 0 points. And there we are at our 0 point. All right. Now, if we bring in our volume, there it is. Now, I can bring up the level of maths channel 2. Speed up the frequency of this thing. Level of maths back down to 0. Increasing it. So this is generally just acting as an attenuverter. And as I bring this up now, I'm going to add a positive DC voltage to this, and this is going to offset the signal. Now we have to add this. We could do this with maybe certain mixers, but an DC offset is essentially what we're bringing in. And watch the signal on the scope here. Oh, you're not going to see the change on the scope. We have to go out from up here and then back down. And excuse my funky routing here. Okay, so now we're looking at the green one. Okay, so level increases. All right, and let's look at this. Okay, so there's our range. Let's speed up the frequency a little bit. even at 0 volts, if we add a DC offset, it will simply offset that 0 volts. And we've got a cat in the studio. All right. So there we have it. Uh, now this is hardly the length and breadth of LFOs, but we're and ideally we would have a separate bipolar function because this doesn't exactly replace or a unipolar function, I should say. This doesn't exactly replace a unipolar LFO. It'd be nice to have one where we could start from 0 and rise and come back to 0. Maybe something that we could get out of the the quad envelope from Maleko, which allows us to go into a looping mode and give effectively create an LFO out of envelopes. So that might be something to explore on another day. But now we're getting into some alternative devices, which we can save and talk about on another show. Questions, suggestions, things that we might try, things that you like to use your LFO for. Let us know in the chat, in the comments. I'd love to hear alternative techniques, more complicated techniques, interesting routing. Do you have a patch that you like to turn to that makes use of LFOs? Make a video and tag us. Put it in the comments so we can all see it. I think that might be an interesting thing here. Oops, just need one LFO for that. So yeah, you could, let's see, you could mult that LFO out to your two filters. Yeah, and you might need to invert one of those, right? We might need well, I guess actually, if we have a low pass and a high pass filter, they'd just be modulating exactly up and down the same. We just have to set the frequency cutoff position for those two filters. So we could certainly do it that way. Yeah. LFOs. Now, maybe we'll also connect the dots back to, Max for Live in a future week when we have some more time to look at how we can implement other LFOs, how we can implement and locate some of these functions, and LFOs are largely the same from device to device, though certain ones of these functions might be missing or other functions might be added, like those bipolar, unipolar switches, like maybe delays. Sometimes we see a delay built into an LFO, kind of an attack time where we fade in over time. This is something we need an envelope and a VCA to make happen. In addition to our LFO in most analog settings, right? It's an extra VCA and a long attack envelope, controlling the intensity, the level, the amplitude of that LFO. So that's another thing we might find. I think it's really nice, in my opinion, on the quad LFO to have that tempo control because we have that extra bit of kind of expected functionality that at other times we might not see on an LFO. So, yeah. Well, I think we've spent a lot of time on LFOs today, and we'll maybe return back to this topic.
I've been hypnotized by the LFOs. So.
That's they seem to have that effect, right? So maybe we'll come back to this topic in a future week, and I think There's a lot more to talk about. Um, yeah, so often I just want the positive cycle of the LFO. That's where you need those unipolar LFOs. You could also use wave rectification. That might be another option, Wambra. That would effectively zero out any signal that went below uh, the 0 point in terms of CV. Um, I think that's half wave rectification, and then full wave rectification would take that anything that went below 0 and invert it into the positive range, which could also maybe be an interesting thing to explore. There are modules that do that. Maths can do that. Uh, yeah, that's again like that starts to get out of just the LFO range maybe, but into um, wave manipulation, um, wave shaping, to a certain degree, I suppose. So we'll talk about that on another day and make a whole other stream about that stuff. So uh, let us know in the comments. Give us some feedback. Should we uh, talk more about this stuff? Should we shut up and talk less about it? Do you want to hear more audio? Uh, give us some feedback. We're building this thing. It's a new thing for both of us, and live streaming is not something I have a great deal of experience with, but we're trying to build this thing up, and we really appreciate your guys' feedback and participation. So thank you for showing up, and thank you for keeping it a little bit alive in here. We really appreciate that. So next week we have the amazing Travarsi coming in to talk to us about what she's been doing in Southern California with the SoCal uh, Synth Collective. I'm saying that wrong. I'm really embarrassed that I'm saying that wrong. But yeah, next week we're going to have Travarsi in studio talking about some of her preferred techniques, her her story. You know how she got to where she is now. Uh, uh, you know, she's an extremely busy performer in Southern California, incredible techno performer. She performs live with modular and hardware. She just did an event at Perfect Circuit last week for the new Hydra synth. She did an event a couple weeks ago there with noise engineering. Incredible musician. We're really excited to have her on the show next week at noon, again on Saturday. So we really hope to see you guys then. Until then, please keep an eye on our Instagram, our Twitter. We're at Voltage Control Lab on Instagram, at V Control Lab on Twitter, and we will be posting up the link for the next show. We'll probably have some more polls, asking for input on what we should do for upcoming shows, including maybe parts of next week's show. So please, by all means, catch up with us on that end. And thank you again. See you next time.
Have a good day.
Take care.